At 2:06 in the afternoon Eastern Daylight Time on Saturday, May 30, 2026, a piece of the solar system roughly 5 feet wide, 1 6 meters across, dense, ancient, traveling at something close to 120,000 kilometers per hour, entered Earth's atmosphere over northeastern Massachusetts, decelerated catastrophically against the air column above Cape Cod Bay, and exploded with the kinetic energy of approximately 230 tons of TNT. NASA confirmed it. The geostationary lightning mapper on the GOES weather satellite recorded it. Sonic booms shook houses across 9 states. The American Meteor Society logged 132 verified eyewitness reports across Connecticut, Delaware, the District of Columbia, Maryland, New Jersey, New Hampshire, New York, North Carolina, Pennsylvania, and parts of Canada within the first 6 hours. Live science 230 tons of TNT. Let me say that again so it registers. 230 tons of TNT, released in a window of less than 2 seconds, roughly 19 miles above a population corridor that includes Boston, Providence, and Worcester. That is somewhere between 15 and 20 times the explosive yield of the largest conventional bomb in the United States military arsenal, released into the sky in broad daylight. On a Saturday afternoon, while people were grilling, and here is the part that should stop you cold. The Cape Cod bolide was not the only one. It was not even the only one that weekend. It was the loudest member of a cluster. 5 distinct, separately tracked, separately cataloged fireball events over the United States and the immediate North American sky, all occurring within a span of roughly 96 hours, between Saturday, May 30 and Tuesday, June 2. 5 fireballs, 4 days, spanning from Cape Cod to Oregon to the Texas-Mexico border to the Ohio Valley, reported in aggregate by more than 700 witnesses on the ground. You did not hear about most of them. You are watching the cosmic forecast, and the question we are walking through tonight is a question that the American Meteor Society, the oldest amateur meteor organization in the world, founded in 1911, the data backbone for every public fireball report in this country, published a formal statistical analysis about on the 3rd of June. The question is whether something has measurably, physically, statistically changed in the population of small bodies arriving at Earth in 2026. Not whether the headlines are louder. Not whether the doorbell cameras are better. Whether the actual number of large, energetic, atmosphere-disrupting objects is moving outside the band that the last 20 years of data would predict. American Meteor Society, the answer, as you will see, is uncomfortable. The answer is that the AMS analysis, published with their raw radiant data, their Poisson statistical model, the Python script available for anyone with a laptop to audit, places the first quarter of 2026 at 3.9 standard deviations above the established baseline at the most diagnostic threshold of fireball size. That is a 1 in 21,000 probability of occurring by chance. That is not increased awareness. That is not ring doorbells. That is a signal. If this has you hooked, subscribe to the Cosmic Forecast so you don't miss what comes next, because this story is just getting started. Drop a comment below. I want to know where in the world you're watching from, what time it is where you are, and your honest take on one question. When a signal this strong appears in the orbital debris environment and the public still mostly hasn't heard about it, what does that say about the gap between what science is observing and what the public is told? That is the central tension of tonight's broadcast. Sit with it. This is not a video about panic. We are not going to tell you the sky is falling. We are going to walk you through 5 events, 5 datasets, 5 threads of evidence. And we are going to do what I have been trained to do on this channel. Separate what is known from what is modeled from what is uncertain. name the open questions, and refuse to oversell the conclusion. But by the end of the next 18 parts, you will understand why a planetary scientist at Lowell Observatory described the question of whether the near-Earth environment has changed as the question everybody wants answered, and why the answer he and his colleagues are giving cautiously, hedged but in print, is that something appears to be different in 2026. You are inside it right now. You have been inside it for 5 months, and you have probably never once stopped to think about it. Let me walk you through it. Before we go anywhere, before the science, before the physics, before the conspiracy theories, before the systemic implications, I want to do the boring part. I want to list, in chronological order with sources, the 5 fireball events that occurred over American and immediately adjacent skies between Saturday, May 30, 2026, and Tuesday, June 2, 2026. I want you to have the receipts in front of you so that, when the rest of this broadcast gets into the harder questions, you cannot say I did not show you the spreadsheet first. Fireball 1. Saturday, May 30, 2026, 2:06 p.m. EDT, Cape Cod Bay, Massachusetts and southern New Hampshire. This is the headline event. NASA confirmed it via the GOES geostationary lightning mapper, which detected the optical flash from orbit. The object was approximately 5 feet across, 1 6 meters, and entered the upper atmosphere at a velocity in the neighborhood of 120,000 kilometers per hour. Initial NASA estimates put the energy released at breakup at approximately 230 tons of TNT. WCVB Boston reported the figure verbatim from NASA Meteoroid Environment Office Communications. Sonic booms were heard from Maine to Maryland. The American Meteor Society's preliminary event logged more than 200 reports, with reports from Connecticut, Delaware, D.C., Maryland, New Jersey, New Hampshire, New York, North Carolina, and the surrounding region. WCVB Boston Fireball 2, Saturday, May 30, 2026, evening approximately 22:10 local time, 2 time zones spanning the Mexico-United States border region. AMS Event 3869-2026. 37 verified reports. This was a separate object, on a separate trajectory, on the same calendar day as the Cape Cod event, but more than 6 hours later and over 1,500 miles south. The International Meteor Organization cataloged it independently of the New England event. There is no plausible kinematic relationship between Fireball 1 and Fireball 2. They were on different orbits, arriving on different vectors. They were close in time only by accident. International Meteor Organization Fireball 3, Saturday, May 30, 2026, late evening Pacific Time, California, Nevada, and Oregon, 33 reports logged by the AMS. A separate event from the Cape Cod and Mexico events, visible across the high desert and the Sierra Nevada. Witnesses described a slow, fragmenting, multi-stage breakup typical of a deep penetrating bolide of perhaps 30 to 50 centimeters across, too small to make ground, large enough to produce sustained luminosity for several seconds. Fireball 4, Sunday, May 31, 2026, late afternoon and evening Eastern Time, another northeastern United States event. This is a second northeastern fireball, separate from the Saturday Cape Cod event, drawing additional reports from the same general region. The AMS logged events of 30 and 32 reports on May 31. Independent confirmation came from a daytime bolide widely shared on Fox 29 Philadelphia, citing AMS data and noting witnesses from CT, DC, DE, MD, NJ, NH, NY, North Carolina, and Pennsylvania. Fox 29 Philadelphia Fireball 5, Monday, June 1, 2026, evening Central Time, Illinois, Indiana, Kentucky, Michigan, and adjacent states. 242 reports filed with the American Meteor Society in the first 48 hours. The Ohio Valley event. And then less than 24 hours later, Tuesday, June 2, a sixth event drew 256 reports. The cluster, in other words, did not stop at 4 days. It just kept arriving. 5 events, 4 days. 3 trajectories crossing 3 different parts of the country. 2 NASA confirmations, including the GOES satellite detection. 1 statistical context. The AMS analysis showing that 2026 is running at twice the historical rate of fireballs with 50 or more witnesses. Now, here is the rhetorical move I want to flag for you before we go further. It is easy, it is in fact natural, to look at a list like the one I just gave you and reach for a single, neat, satisfying causal explanation. 5 fireballs in 4 days means something is hitting Earth. That sentence is intuitive. It is also wrong, in the strict sense, and the way it is wrong is more interesting than the way it would have been right. What I am going to show you in the next 16 parts is that the cluster of 5 is not the story. The cluster is the symptom. The story is what the cluster, placed against a 5-month statistical record going back to January, is telling us about the orbital environment Earth has been moving through since the start of this calendar year. And that signal, the one in the AMS analysis published on June 3, is the one that should be on every front page in the country and is on essentially none. Let me walk you through why. On the 3rd of June, 2026, the American Meteor Society Operations Manager Mike Hankey, the same data steward who built and maintains the Fireball reporting database that every news outlet ultimately cites whether they say so or not, published a formal statistical analysis of the first quarter of 2026 against the historical baseline. The document is titled, with characteristic AMS understatement, Q1 2026 has something changed in the near-Earth meteoroid environment. It runs with raw data attached. It includes a published Python script, Poisson Analysis Q1 2026, Pi, that allows any reasonably competent analyst to reproduce the statistical tests from the underlying CSV file. It is not a press release. It is not a tweet. It is a piece of citizen science scholarship with the math exposed. American Meteor Society Q1 2026 analysis. Let me walk you through what it says, because the framing is going to matter for everything that follows. Number 1. The total number of Fireball reports filed in the first quarter of 2026 was 2,322. That is the highest first quarter total on record. And this is the part most reports get wrong. It is only marginally above 2022, which logged 2,168, and 2021, which logged 2,065. Total volume alone, in other words, does not establish a signal. If you stopped at total reports, you would conclude that 2026 is busy but not exceptional. The reporting artifact crowd, the "it's just more Ring doorbells" crowd, would have a defensible argument. Number 2, the signal is not in the total, the signal is in the distribution. The AMS broke the data into thresholds. Events with 25 or more reports, events with 50 or more reports, events with 100 or more reports. As the threshold rises, the 2026 deviation from baseline grows. That is the diagnostic pattern of a real physical change in the incoming material rather than a reporting artifact. Reporting artifacts inflate small events the most because more cameras catch more small flashes. Physical changes inflate the large events the most because larger objects are rarer in the natural population, and any uptick is more visible against a small baseline. At 25 reports or more, 2026 logged 70 events compared to a baseline average of 43. That is a 63% increase. At 50 reports or more, 2026 logged 40 events, against an average of 20. That is double the historical rate. At 100 reports or more, 2026 logged 16 events, against an average of 8. Also double. And at the diagnostic threshold, 50 or more reports, the deviation from baseline is 3. 9 standard deviations, 3.9 sigma. In plain English, the probability of getting this many large fireballs in a single quarter by random chance, given the historical distribution, is approximately 1 in 21,000. The Poisson p-value, if you want it in numbers, is 0.5. Let that number breathe for a second. A 1 in 21,000 result, in any other scientific discipline, is the kind of result that ends careers if it is wrong and starts careers if it is right. In particle physics, 3 sigma is evidence, 5 sigma is discovery, 9 sigma sits in between. It is well past the line where you stop saying interesting coincidence and start saying look harder. Number 3, the signal is corroborated by sonic boom rates. Sonic booms are an independent measure of fireball energy. They are produced only when the object is large enough and dense enough to penetrate deep into the atmosphere and either fragment explosively or generate sustained hypersonic shock. In Q1 2026, 82.5% of large events produced sonic booms. That places 2026 at the absolute top of the historical frequency distribution. You cannot fake a sonic boom with a Ring doorbell. The booms either happen or they do not. Number 4, the signal is corroborated by meteorite recoveries. The AMS Q1 2026 catalog includes multiple confirmed meteorite falls. Diogenite-class specimens recovered from a daytime bolide over Western Europe on March 8. Eucrite specimens recovered after a 7-ton, 2-meter asteroid disintegrated over Ohio on March 17. And an ordinary chondrite fragment that penetrated the roof of a home in the Ponderosa Forest neighborhood of Houston, Texas. On March 21, that last one, a 1-ton meteoroid that broke up 29 miles above the metro area at 4:40 p.m. Central Time and produced a 26-ton TNT airburst. Mike Hankey of the AMS told Space.com that worldwide, recovered meteorite falls average roughly 10 per year. 2026 was running well ahead of pace at the first quarter mark. The explanation is complete. This is not a malfunction of the reporting system. It is a math problem and the math has changed. I want to slow down here because the phrase 9 standard deviations above baseline is going to do a lot of work in this script. And if you do not understand exactly what it means, you cannot evaluate the rest. Let me put it in a framework that actually means something. Think of the standard fireball distribution as a target you are shooting at. Each year, you fire 365 arrows, and most of them cluster in the bulls. That is your baseline. Some years, by chance, more arrows land outside the bullseye. That is normal variation, the standard deviation. 1 standard deviation away from the bullseye is the band where roughly 2/3 of your years should land. 2 standard deviations away is the band where 95% of years land. 3 standard deviations away is where about 99.7% of years land, the band that contains essentially all of the random year-to-year variation you would ever expect to see. 9 standard deviations is outside that band, significantly outside it. It is the territory where you no longer say unusual year and start saying the target moved. Now lay another piece of evidence on top of it. The AMS analysis didn't stop at the overall fireball count. They went deeper. They looked at the radiance, the points on the sky where the meteoroids appear to come from when you trace their trajectories backwards. In a normal year, Fireball radiants are distributed across the sky in a known pattern, with concentrations near the Antelian zone, the point opposite the Sun, and along the ecliptic plane, where most asteroidal debris orbits. In Q1 2026, the radiant distribution was anomalous in two specific regions. The Antelian zone, right ascension 150 to 200 degrees, logged 14 events against a baseline of 3.6, that is 4.1 sigma above expectation, a 1 in 20,000 result in that specific region of the sky. The high declination region, declinations greater than 70 degrees, which is the part of the sky near the celestial North Pole. The part of the sky that has essentially no major known meteor showers, logged 12 events against a baseline of 2.4, that is 4.3 sigma above expectation, a 1 in 50,000 result. Here is what makes that observation so much worse. Radiant distribution is independent of reporting bias. A doorbell camera does not know which direction the meteor was going. The radiant is calculated post hoc from the trajectories reconstructed by AMS staff from witness reports and video. If reporting bias were inflating the numbers, you would expect the inflation to be uniform across the sky. Instead, the inflation is concentrated in two specific regions, one of which, the high declination region, does not correspond to any known meteor shower or stream. That is the kind of pattern that, if you saw it in any other dataset, you would conclude that something specific is going on, not generally more activity. Specifically more activity from specific directions, the most likely explanations, and the AMS is careful to call them hypotheses, not conclusions, are these. 1. A previously unidentified meteoroid stream is currently intersecting Earth's orbit, possibly the debris trail of a comet that broke up sometime in the last few hundred years. Possibly a stream from an asteroid family disrupted by a recent collision. 2. The general background flux of small near-Earth objects has increased, and the increase is showing up first at the rare, large end of the distribution, because that end has the smallest baseline. 3. Some combination of 1 and 2. What it is not by the AMS's own analysis is a reporting artifact. The math rules that out. The sonic boom rate rules that out. The radiant clustering rules that out. The meteorite recoveries rule that out. There is real material in the upper atmosphere, in larger quantities than the baseline would predict, with statistically significant clustering in specific sky regions. The signal is real. The signal is physical. The signal is ongoing. The question is what is causing it. And to even begin to ask that question, we have to do something most coverage of these events never does. We have to back up and look at the population of objects that produce fireballs in the first place. Because if you do not understand the population, you cannot understand the anomaly. Let me walk you through it. Earth, as you read this, is moving through a haze. The haze is invisible to the naked eye, mostly invisible to ground-based telescopes, and only partially mapped by radar. The haze is made of small bodies, dust, pebbles, rocks, occasional boulders, very occasional house-sized objects, left over from the formation of the solar system, supplemented by fragments produced by ongoing collisions between larger objects in the asteroid belt, and by the slow shedding of material from comets. NASA's Planetary Defense Network, by congressional mandate, is tasked with finding and tracking near-Earth objects that are 140 meters and larger. That is the size threshold at which an impact would produce regional, rather than local, devastation, the threshold at which a single object could end a city. We have cataloged, as of mid-2026, the great majority of the 140-meter and larger population. The Chelyabinsk meteor of February 2013, by comparison, was approximately 20 meters across. The Tunguska object of June 1908, the airburst over Siberia that flattened an estimated 2,150 square kilometers of forest, was somewhere in the 50 to 80 meter range. The Cape Cod bolide of May 30, 2026 was approximately 16 meters. Objects smaller than 140 meters are, in NASA's official language, almost impossible to track in space. There are too many of them, they are too dark, they are too small, and ground-based telescopes do not have the survey cadence or sensitivity to catalog them at scale. We do not know how many 1 meter, 2 meter, 5 meter near-Earth objects there are. We have models. The models have wide error bars. NASA Watch the Skies here is what the models say, in rough terms. The flux of meteoroid material at Earth's atmosphere is dominated, in mass terms, by very small particles. Most of the tens of tons of extraterrestrial material that arrives at Earth every day is dust, submillimeter particles that vaporize at high altitude and never produce visible meteors. A small fraction is in the size range that produces ordinary shooting star meteors, particles from millimeters to centimeters in size. An even smaller fraction is in the fireball range, centimeters to meters, large enough to produce sustained luminosity, large enough to occasionally survive to the ground as meteorites. And then at the rare end, you have the events that hit the news, the Chelyabinsk-class events, the Tunguska-class events, the civilization-altering events. These are vanishingly rare under normal conditions. We expect, on average, one Chelyabinsk-class event every 50 to 100 years and one Tunguska-class event every several centuries. Now, the signal in the AMS data is not at the Chelyabinsk end. The events we are seeing are not city killers. They are not even town shakers in most cases. The largest individual event of Q1 2026, the Ohio bolide of March 17, was a 7-ton, 2-meter object releasing 250 tons of TNT. The Cape Cod event of May 30 was a 5-foot object releasing 230 tons of TNT. These are the kind of events that, statistically, Earth should experience perhaps a few times a year. The signal is not that any individual event in this cluster is anomalous in absolute terms. The signal is that the frequency of events in this size class has doubled. And that is where the math gets interesting, because the mass distribution of near-Earth objects follows what astronomers call a power law. There are vastly more small objects than large ones, and the relationship between count and size is roughly predictable. If you double the number of meter-class fireballs hitting the atmosphere, and the population follows the standard power law, then you should also have a corresponding increase in the number of decameter-class objects out there, the Chelyabinsk class, and a corresponding increase in the number of hectometer-class objects, the Tunguska class. This is the part that should stop you cold. If the doubling we are seeing at the meter scale is a real signal, not a reporting artifact, not a random fluctuation, and if it reflects a genuine increase in the population of small Earth-crossing material, then the same physical mechanism that produced that doubling is, by power law scaling, also raising the probability of larger events. Not certainly producing them, raising the probability. The dice are loaded, not by a lot, but measurably. This is what makes the AMS analysis so unusual. It is not just describing more fireballs. It is implicitly describing a possible shift in the near-Earth object population that, if confirmed, has implications for planetary defense risk assessment that extend well beyond the meter-class events you can watch on YouTube. That is the part most people never heard about. Now I want to do something the responsible version of this conversation requires. I want to steelman the argument that there is no signal, that what we are seeing is normal seasonal variation amplified by media attention and camera proliferation. Because if I do not do that, I cannot legitimately tell you the signal is real. The seasonal argument goes like this. Spring in the northern hemisphere is fireball season. NASA has been saying this for years. Bill Cook of the NASA Meteoroid Environment Office told Space Weather. That in the weeks around the March equinox, the rate of very bright meteors increases by 10 to 30%. The exact mechanism is not fully understood. Some astronomers believe Earth's orbit takes it through a region of space with more large debris during these weeks. Possibly the leftover trails of comets and disrupted asteroids that share orbital characteristics with Earth's path around the Sun. But the empirical fact is well established. February through April, fireballs go up. NASA watch the skies, so one defensible position is: March 2026 looks busy because March always looks busy. And the cluster of late May fireballs is just the tail of fireball season, extending into early summer. That sounds elegant, and it is, but it is also a confession, because the AMS analysis explicitly controls for seasonal variation. The baseline they used, the 2018 to 2025 average, is itself a Q1 baseline. They are not comparing 2026's Q1 to a Q3 average. They are comparing Q1 to Q1, fireball season to fireball season. And against that controlled baseline, 2026 is still 3.9 sigma above expectation at the most diagnostic threshold. In other words, yes, fireballs go up in spring. Everyone knows that. The question is, do fireballs go up this much in this spring compared to other springs? And the answer is yes, by a margin that random chance cannot easily account for. The second Steelman is the camera proliferation argument. The argument is that more doorbell cameras, more dash cams, more security cameras, and the rise of AI chatbots that direct curious users to the AMS reporting site are all conspiring to inflate the count. Mike Hankey of the AMS told Space that AI chatbots in particular are sending people to the AMS website when they ask the chatbot about a fireball they saw. People go to AI when they need to learn something, so if they saw a fireball, they might go to the AI, and the AI does say to report your sighting to the AMS, Hankey said. Space. That is a real factor. It is plausibly inflating the total count. But, and this is where the AMS Q1 analysis becomes critical, it cannot inflate the distribution. Camera proliferation and AI-directed reporting inflate the lower thresholds, the events with 5 or 10 or 20 reports. They cannot doubly inflate the events with 100 or more reports, because at 100 reports you have already reached saturation. You have witnesses across an entire region. Multiple states, multiple time zones in some cases. You cannot add more cameras to an already saturated event, and yet the doubling is concentrated precisely at the high witness end. Which means the camera argument explains some of the inflation, but it cannot explain the part of the inflation that matters. That part is physical. The third Steelman is the clustering illusion. This is the argument that human pattern recognition is biased towards seeing meaningful sequences in randomly distributed events. If you scatter dots on a wall by throwing paint at it, your eye will find shapes, faces, animals, letters that are not actually there. Apply that to fireballs, and you get the intuition that 5 fireballs in 4 days means something, when in fact, given enough fireballs per year, you are guaranteed to occasionally have clusters of 5 within 4-day windows, just by random chance. The clustering illusion is real. It is a cognitive bias I respect and I want to honor it, but here is the rebuttal. The 5 fireball cluster of May 30 to June 2 is not, by itself, a statistical anomaly. If you took the average fireball rate and ran a Monte Carlo simulation, you would absolutely produce 4-day windows with 5 large events occasionally. The cluster in isolation is consistent with random variation. The cluster is not the anomaly. The anomaly is the 5-month context the cluster sits inside. January through May 2026, taken as a whole, has produced fireball rates that are not consistent with random variation in the historical distribution. The cluster of May 30 to June 2 is what you would expect if the underlying rate had shifted upward. It is the kind of thing you see when the loaded dice lands showing 6 several times in a row, not because any individual roll is impossible, but because the underlying probabilities have changed. This is the part where I have to be precise. The cluster is not the proof. The cluster is the example. The proof is in the 5-month statistical record. And the statistical record, as audited and published by the AMS on June 3, 2026, with the math exposed, says the underlying rate has shifted. The clustering illusion does not apply to the AMS analysis. It applies to the news coverage of the cluster. There is a difference, and the difference matters. Let me bring you back to Saturday, May 30, 2026, 2:06 p.m. Eastern Daylight Time, and let me walk you through what actually happened over Cape Cod. Because this is the most thoroughly instrumented fireball event in American skies in 2026, and the data tells a story that the headline number alone does not convey. The object entered the upper atmosphere on a trajectory that brought it down over northeastern Massachusetts at an estimated velocity of approximately 120,000 kilometers per hour. That is 75,000 miles per hour. That is approximately 33 kilometers per second. For comparison, the International Space Station orbits at roughly 28,000 kilometers per hour. The Cape Cod bolide was moving more than 4 times that speed. At those velocities, the atmosphere stops being a fluid medium and starts being something closer to a wall. The object was approximately 1.6 meters in diameter, about 5 feet across, and based on the energy release and the estimated entry velocity, NASA's Meteoroid Environment Office calculated a mass somewhere in the range of several hundred kilograms to a few metric tons, depending on the assumed density of the parent material. If it was a typical stony chondrite, density around 3 grams per cubic centimeter, the mass was probably in the range of 2 to 4 tons. If it was denser, a metal-rich object or a primitive carbonaceous chondrite that compressed during atmospheric entry, the mass could have been higher. Live science, the energy release at fragmentation was approximately 230 tons of TNT equivalent. Let me put that in a framework that actually means something. The largest conventional bomb in the United States military arsenal is the GBU-43B massive ordnance air blast, the so-called mother of all bombs, which yields approximately 11 tons of TNT equivalent. The Cape Cod bolide released roughly 20 times that energy. The largest air-burst nuclear weapon ever tested by the United States, Castle Bravo, 1954, yielded 15 megatons, or 15 million tons of TNT. The Cape Cod bolide was approximately 1/65,000th of Castle Bravo's energy. It was not, by any stretch, a weapons-grade event. It was a moderate fireball by historical standards. And it shook houses in 9 states. The geostationary lightning mapper on the GOES weather satellite, an instrument designed to detect lightning flashes from orbit, not meteors, recorded the optical pulse from the airburst. This is one of the reasons NASA was able to issue confirmation so quickly. The same instrument that catches thunderstorms catches sufficiently bright bolides as a side benefit. The Cape Cod event registered cleanly on the GLM. The flash signature was distinct from any meteorological lightning event. NBC Boston via Pamela Gardner witnesses across the region reported a daylight flash, described by one Massachusetts witness as brighter than the sun for a moment, even though the sun was right there. That is a useful empirical detail. To be brighter than the sun in clear daylight, a bolide has to reach an absolute magnitude of approximately -17 or brighter. That is the threshold at which we move from calling something a fireball to calling it a superbolide. The Cape Cod event was at or near that threshold. Sonic booms were the most widely reported physical effect. Multiple home security systems captured the booms. The boom signature was a sequence, not a single bang, but a rolling concussion that lasted several seconds. That sequence is consistent with fragmentation. The object broke apart in stages, each fragmentation event producing its own shock wave. The shock waves arriving at ground stations slightly offset in time as they propagated down through the atmosphere. Residents north of Boston reported their houses shaking. There were no reports of structural damage. There were no reports of casualties. There were, as far as we know, no recovered meteorite fragments. The trajectory took the object out over Cape Cod Bay, and any surviving material almost certainly fell into the water and is, for practical purposes, unrecoverable. Here is the part that most coverage missed. The Cape Cod event, taken in isolation, is not unusual. Earth experiences several events of this approximate energy class every year. A 230-ton TNT bolide over an unpopulated area, or an ocean would never make the news. The Cape Cod event made the news because it occurred in broad daylight over one of the most densely populated regions of the United States, generated sonic booms across 9 states, and was captured by multiple instruments: satellite, ground witness, camera, doorbell, NWS Doppler. Take Cape Cod out of the news cycle, and you still have 4 other fireballs in the same 4-day window. Add Cape Cod back in and you have a cluster that, against the backdrop of the AMSQ-1 analysis, becomes part of an ongoing pattern. That is the framing that the headline coverage missed, because the headline coverage is event-driven. The cosmic forecast is not event-driven. The cosmic forecast is pattern-driven. And the pattern is what matters. The Cape Cod event got the news cycle. The other 4 did not. Let me give you the missing 4 in detail, because the asymmetry of coverage is part of the story. Fireball 2. Late evening Saturday, May 30, 2026. The Mexico-United States border region. AMS event 3869-2026 in the international catalog. 37 verified reports. The event occurred at approximately 22:10 local time, with witnesses spanning 2 time zones on the southern flank of the U.S. continental footprint. The trajectory was, as best the AMS preliminary reconstruction suggests, oriented roughly east to west, moving across the border region into northern Mexico. Witnesses on the United States side described a slow, multicolored event, a long-duration meteor, with color changes from white to green to orange as different elements in the meteoroid's composition vaporized at different altitudes. Green typically indicates magnesium or nickel iron. Orange typically indicates sodium. The color shift implies a compositionally heterogeneous object, likely a chondritic stony meteoroid with metal inclusions, rather than a pure iron or pure stone. Estimated size, based on the visual magnitude and duration, somewhere in the range of 50 centimeters across. Estimated energy, perhaps a few tons of TNT equivalent. A small bolide, but a bolide. This event got no national coverage. It got Spanish-language regional press in Sonora and Chihuahua, and that was it. If you watched American national news that night, you did not hear about it. Fireball 3. Late evening Saturday, May 30, 2026. California, Nevada, and Oregon, 33 reports. The event was logged in Pacific time, several hours after the Cape Cod and southern border events. Witnesses across the Sierra Nevada, the Great Basin, and the Pacific Northwest. Reports from coastal Oregon and from inland Nevada both placed the event high in the sky, suggesting a high-altitude entry, probably in the range of 60 to 90 kilometers altitude, and a relatively shallow entry angle, which is consistent with the long visual duration witnesses reported. The California-Nevada-Oregon event is the one I find most telling, for one specific reason. The three Saturday night fireballs, Cape Cod, the southern border, and the western, are not on a single trajectory. They are not fragments of one parent body. They are three independent objects, on three independent orbits, arriving at three different parts of the United States within a window of perhaps 8 hours. Astronomically, that is a coincidence. Statistically, given the 2026 elevated fireball rate, that is exactly the kind of coincidence you would expect to see more of in 2026. The clustering, in other words, is consistent with elevated background rate. It is not consistent with a single coordinated event. Fireball 4, Sunday, May 31, 2026. Northeastern United States, late afternoon and evening Eastern Time. The American Meteor Society's preliminary log shows multiple events on May 31, including 30 report and 32 report events, and a secondary daytime fireball that drew 132 reports across CT, DC, DE, MD, NJ, NH, NY, North Carolina, and Pennsylvania, as confirmed by Fox 29 Philadelphia citing AMS data. Fox 29 Philadelphia, this is the fireball that nearly got missed entirely. Less than 24 hours after the Cape Cod event, a second daytime fireball was reported across much of the same general region. The two were on different trajectories. Cape Cod's bolide came in over Massachusetts. The May 31 event was visible from points well to the south and west, but the regional overlap means many of the same witnesses reported both. AMS staff had to do additional trajectory work to confirm the two were separate events and not double-counted reports of a single event. The conclusion: two separate objects, two separate trajectories, two separate events, 24 hours apart, over substantially the same population corridor. That kind of follow-on event in the same region in the same week is the kind of thing that, in isolation, would be remarkable. In the context of the AMSQ1 analysis, it is consistent with the elevated rate. Statistically expected in the sense that if the underlying rate has doubled, then back-to-back regional events become roughly 4 times more likely. Fireball 5, Monday, June 1, 2026. Illinois, Indiana, Kentucky, Michigan, and adjacent states. 242 reports filed with the AMS in the first 48 hours after the event. This is the event that, by witness count alone, was actually the largest of the cluster. More witnesses than Cape Cod, more witnesses than the May 31 event. And yet, because it occurred in the central Midwest, away from the dense East Coast media corridor, it got vastly less national coverage. The Ohio Valley event was a slow, prolonged fireball, visible across multiple states, with reports of multi-stage fragmentation and trailing material. Witnesses described a fragmentation track that lasted for several seconds, suggesting a relatively large object, possibly a meter or more across, that broke up over a period of distance rather than in a single explosive event. The AMS has not yet released a final energy estimate, but witness duration and color reports are consistent with an object in the same general class as Cape Cod, meter scale. Hundreds of tons TNT equivalent. And on Tuesday, June 2, a sixth event, 256 reports, extended the cluster into a fifth day. These are the 4 fireballs that did not make front pages. They are also the 4 that, taken together, give the cluster its statistical weight, Cape Cod alone is a story. Cape Cod plus 4 others, all in 4 days, all over the same continent, against the backdrop of a 3.9 sigma statistical signal, is something else entirely. It is the kind of week that, in any other year, would have astronomers on cable news for a month. In 2026, it got a couple of local news segments and a NASA tweet. That gap between the size of the signal and the size of the coverage is itself part of what the cosmic forecast exists to address, because the gap is widening. And the longer it widens, the harder it gets to communicate what the science is actually saying. Part 9. The Houston Roof, the Ohio Meteorite, and the European Bolide. If the Q1 2026 numbers feel abstract, let me ground them in 3 specific events from earlier in the year that establish the physical reality of what is happening. These are not statistical aggregates. These are individual fireballs that produced recovered meteorites, physical objects you can hold in your hands, currently being analyzed in laboratories on 3 continents. March 8, 2026. Daytime bolide over Western Europe, France, Germany, Switzerland, Belgium, the Netherlands. 3,229 reports filed with the International Meteor Organization and the AMS combined. The duration was unusually long, approximately 5.5 seconds, which is the hallmark of a slow, shallow-angle entry. Slow-angle entries produce more witnesses because the trajectory length is enormous. Mike Hankey of the AMS noted to that, when a trajectory is hundreds of miles long, more people are going to see it. The March 8 European bolide had a trajectory that may have spanned 300 kilometers across multiple countries. The recovered specimens, fragments collected from impact sites in agricultural fields across France and Germany, are still under formal study, but preliminary analysis suggests diogenites. Diogenites are a class of a chondrite meteorite, igneous in origin, believed to come from the deep crust of the asteroid 4 Vesta, the second largest object in the asteroid belt. If the March 8 specimens are confirmed as diogenites, they trace back to a specific, identifiable parent body. That gives planetary scientists a unique opportunity to study material from a deep crustal layer of Vesta. March 17, 2026, Ohio, USA, daytime bolide and meteorite fall. Witnesses from the northeastern United States and Canada reported a very bright daytime fireball the morning of March 17, 2026. The object was a 7-ton, 2-meter asteroid that entered the atmosphere over Lake Erie. The energy release was estimated at 250 tons of TNT, comparable to the Cape Cod event of May 30, but with a larger parent body that survived deeper into the atmosphere. Recovered meteorite specimens were classified as eucrites. Eucrites, like diogenites, are believed to come from 4 Vesta, specifically from the upper crustal layers. This is a remarkable scientific opportunity. 2 confirmed falls, March 8 in Europe and March 17 in Ohio, both with meteorites traced back to the same parent body, Vesta, 9 days apart. That is the kind of pairing that, if confirmed by detailed analysis, raises the question of whether both objects originated from the same disruption event at Vesta, possibly a relatively recent collision that scattered material into Earth-crossing orbits. If that turns out to be the case, the Q1 2026 anomaly may have a specific astronomical explanation: a fresh Vestian debris stream currently intersecting Earth's orbit. That is a hypothesis. Not theory yet, but it is a hypothesis that is testable. The isotopic and mineralogical analysis of the recovered specimens in laboratories at the Sorbonne, Heidelberg, the Smithsonian, and the Lunar and Planetary Institute will either confirm a common parent or rule it out. March 21, 2026, Houston, Texas, USA. A 1-ton meteoroid broke apart 29 miles above the Houston metropolitan area at 4:40 p.m. Central Time, producing sonic booms across the metro and a 26-ton TNT equivalent airburst. A fragment of the meteoroid, surviving the disintegration and falling through the lower atmosphere, penetrated the roof of a home in the Ponderosa Forest neighborhood. NASA tracked the debris cloud via Doppler radar in the minutes following the airburst. Preliminary analysis identifies the recovered fragment as an ordinary chondrite, the most common class of meteorite, originating from the inner main belt. A Meteor-class object disintegrating over a major American metropolitan area, sending a fragment through the roof of a home, with the trajectory tracked by NWS radar. This is the kind of event that, in any other year, would be a top-of-the-fold national story for a week. In Q1 2026, it was one of dozens of events in the AMS log. That sentence should sit with you for a second. When the rate is high enough that a meteorite penetrating an American home becomes a one-day story. The rate is high enough that the public's intuition about how common these events are starts to mislead. The Ponderosa Forest incident in a normal year would be cited for the next decade as an example of how meteorite damage to property does occur. In 2026, it became background noise. That is what an elevated rate looks like, not catastrophe, not a single defining event. A steady accumulation of incidents that, taken individually, do not break out of the local news cycle, but taken together, represent a shift in the operational baseline of the upper atmosphere. The signal is in the aggregate. The aggregate is what gets missed. I want to take a section here to address something directly, because if I do not, the algorithm will fill the gap with the bad version. There is a conspiracy-flavored framing of the 2026 fireball surge that has been circulating on certain corners of the internet since March. The framing goes roughly like this. The fireball uptick is evidence that something the government is not telling us about is happening, a Planet X interaction, a secret military weapons test. An extraterrestrial probe, take your pick. The framing has, as conspiracy framings tend to do, a kernel of correct observation. The rate has gone up, wrapped around a wildly unsupportable causal claim. The cause is something hidden. I want to dismantle this framing carefully, respectfully, and thoroughly, not because the people who hold it are stupid, but because the alternative explanation is, on examination, more alarming than the conspiracy. And the more alarming explanation deserves the attention. Let me do the energy budget math, because that is the cleanest way to settle the question. The total energy released by all observed fireballs in Q1 2026, adding up the AMS catalog entries with reported energies, is on the order of a few thousand tons of TNT equivalent. The Houston event was 26 tons. The Ohio event was 250 tons. The Cape Cod event, later in May, was 230 tons. Adding up the catalog, you get something in the range of 1 to 3 kilotons total energy release over the first 5 months of 2026. That is the order of magnitude. That is approximately 1/15 the yield of the bomb dropped on Hiroshima. Spread across 5 months, over the entire surface area of the Earth's atmosphere, at altitudes mostly above 20 kilometers. That total energy is consistent with a small uptick in natural meteoroid flux. It is not consistent with any plausible engineered source. There is no clandestine weapons program in the world that releases that much explosive energy at high altitude on a recurring schedule, without being trivially detected by radar, satellites, and ground-based seismic networks. The energy budget rules out every military test theory immediately. It is also not consistent with extraterrestrial spacecraft activity in any operationally meaningful sense. The objects entering the atmosphere produce light curves, deceleration profiles, fragmentation patterns, and meteorite compositions that are consistent in every confirmed case in 2026 with natural chondritic or achondritic material. The Ohio meteorites are eucrites. The March 8 European meteorites are diogenites. The Houston fragment is an ordinary chondrite. These are rocks with mineralogy that matches asteroid samples returned by NASA's OSIRIS-Rx and JAXA's Hayabusa missions, with cosmic ray exposure ages consistent with natural objects that have been in interplanetary space for tens of millions of years. There is no anomalous material. There is just more of the normal material. And finally, the Planet X argument. The hypothetical large, unseen planetary body that, in some versions of the conspiracy, is perturbing the asteroid belt and sending objects toward Earth. Here is the problem. A planet large enough to perturb the asteroid belt would itself be observable. Its gravitational effects would have been measured in the orbits of the outer planets. Its thermal signature would have been detected by WISE and NEOWISC. We have looked carefully. The mass range that would be required to produce the observed perturbation, if any existed, would be well above the detection limits of multiple independent surveys. The Planet X explanation requires us to believe that every major astronomical survey of the last 40 years has missed something that should be easy to find. That is not how science fails. That is how conspiracies fail. So if we rule out engineered sources, anomalous compositions, and unseen perturbers, what is left? What is left is the actual answer. And the actual answer is this. Earth is, in the natural course of its orbit, moving through a region of space that contains slightly more material than the baseline of the last 20 years would predict. The most plausible specific explanation, given the radiant clustering and the Vestian meteorite compositions, is that a previously unidentified debris stream, possibly produced by a relatively recent collision in the asteroid belt, possibly the residue of a comet that broke up in the inner solar system, is currently intersecting Earth's orbit. The stream may persist for months, it may persist for years, it may dissipate by next quarter. We do not know. The conspiracy version says someone is hiding the cause. The actual version says no one knows the cause yet, and the science is being done in real time, in the open, with the data published in front of you. Here is why the actual version is more alarming. The conspiracy version implies that the situation is, in principle, controllable. Someone somewhere is in charge of the thing. The actual version implies that the situation is not controllable in any meaningful sense. There is no one in charge of an asteroid debris stream. There is no negotiating with it. There is only observing, modeling, and waiting. And the waiting is the part where the dice are loaded, and the loaded dice keep rolling. The truth is not less worrying than the conspiracy. The truth is more worrying. It is just less viral. That is the gap I keep pointing to. That is the gap the cosmic forecast exists inside of. Let me develop the Vestian debris hypothesis in more detail. Because if the recovered meteorites from March 2026 are confirmed as Vesta origin, the implications are scientifically significant in ways the headlines have not begun to convey. Vesta, formerly 4 Vesta, is the second largest object in the main asteroid belt, after Ceres. It has a mean diameter of approximately 525 kilometers. It is, in the rough taxonomy of solar system bodies, what astronomers call a protoplanet, a body that began the process of planetary differentiation, developing a layered internal structure, core, mantle, crust before it stopped growing. NASA's Dawn mission orbited Vesta from 2011 to 2012 and produced detailed maps of its surface, including the massive Resilvia impact basin at its south pole, a 500-kilometer-wide crater that excavated approximately 1% of Vesta's mass at some point in the last billion years. The Resilvia impact is the source of an enormous quantity of debris in the inner main belt, material we now classify as the Vesta family, or the Vestoids. These are asteroid fragments, in orbits dynamically related to Vesta, gradually working their way out of the main belt into Earth-crossing orbits via the slow gravitational perturbations of Jupiter and Mars over millions of years. The Vestoids are the dominant source of HED meteorites on Earth, Howardites, Eucrites, and Diogenites, a meteorite class that, by total recovered mass, makes up several percent of all meteorites in collections. So Vestoid material falling on Earth is normal. It happens every year. We have specimens going back centuries. What may be unusual about 2026 is the rate. If the March 8 European bolide produced Diogenites, material from Vesta's deep crust, and the March 17 Ohio bolide produced Eucrites, material from Vesta's upper crust, and both events are confirmed by isotopic analysis to share a common parent, then we are looking at a possible specific event, possibly a relatively recent fragmentation of a single Vestoid in the inner main belt that has, in the last several decades or centuries, scattered material into a tight orbital stream that Earth is now passing through. This is, again, hypothesis. The detailed isotopic work that would confirm or refute it is ongoing, but there are reasons it is a hypothesis worth taking seriously. Reason 1. The high declination radiant cluster in the AMSQ1 2026 analysis, the 4.3 sigma signal at declinations greater than 70 degrees, is consistent with a stream of material on a specific orbital plane intersecting Earth's path at high inclination. A near-polar approach to Earth would produce radiance near the celestial pole. That is exactly what the AMS data shows. Reason 2. The Antelian zone enhancement, the 4.1 sigma signal in the Ra 150-200 degree range, is consistent with a population of objects in low eccentricity, low inclination orbits that are nearly co-orbital with Earth. That is exactly the orbital geometry of certain Vestoid subfamilies. Reason 3. The size distribution of the events. The 2026 cluster is dominated by Meteor-class objects, large enough to produce notable fireballs, small enough to be relatively common from a single fragmenting parent. A recent fragmentation event in the inner main belt would produce exactly this size distribution. Reason 4. The temporal persistence. If the surge were a random fluctuation, we would expect it to fade quickly. Instead, the rate has remained elevated through January, February, March, April, and now into the May-June cluster. That is consistent with Earth moving through a sustained debris stream rather than experiencing a one-off cluster. If the Vesta hypothesis is correct, the implications are these. 1. The elevated rate will continue for some period of months, possibly the rest of 2026, possibly into 2027, until Earth completes the transit through the stream. 2. The distribution of meteorite types arriving on Earth during this period will be enriched in HED material, a scientific bonanza for the meteoritics community, which now has the opportunity to study material from a specific protoplanet's interior in unprecedented quantity. 3. The probability of a larger event from the same source population, a decameter class or larger fragment from the same fragmentation event, is elevated, though still small in absolute terms. The dice are still mostly low numbers, but the dice are loaded toward Vesta. This is the part where the math gets interesting, in a way that planetary defense planners are quietly taking very seriously. Because a debris stream that produces a Meteor-class fireball doubling rate is, by definition, also slightly elevating the probability of a larger event from the same stream. not certainly producing one, but raising the baseline, and the baseline was already not zero. That is a sentence worth letting breathe. I want to take a moment to explain the technology that made the Cape Cod fireball confirmable in near real time, because it is a useful illustration of how the operational reality of fireball detection has shifted in the last decade, and why the public should expect to hear about more, not fewer, fireballs going forward. The Geostationary Lightning Mapper, or GLM, is an instrument flown on the GOES-R series of NOAA weather satellites, the satellites that produce the visible light and infrared imagery you see on every weather broadcast in the United States. The GLM was designed to detect lightning flashes from geostationary orbit, providing continuous, all-sky lightning surveillance over the Western Hemisphere with a temporal resolution of roughly 2 milliseconds. It is, in operational meteorology terms, a transformative instrument. The first time we have had real-time lightning data across the entire visible disk of the Earth. But here is what its designers did not initially plan for. The GLM also detects bolides. A bolide is optically similar to a lightning flash, a brief, intense burst of light at a specific point in the atmosphere, except that the spectral signature, the duration profile, and the geographic context are different. The GLM picks up bolides as a side benefit of its primary mission. NASA and NOAA have been quietly building a database of GLM-detected bolides since 2017. The catalog now includes hundreds of confirmed events, with locations, altitudes, energies, and trajectories derived from the satellite data alone, independent of any ground-based observations. This is why NASA was able to confirm the Cape Cod event so quickly. The GLM caught the flash. The signature was unambiguous. The location was constrained. The energy estimate followed within hours. The implications are these. 1. We now have, for the first time in history, continuous all-sky bolide surveillance over the Americas. 2. Every bolide above a certain energy threshold is now detected automatically, whether anyone on the ground sees it or not. 3. The historical baseline of observed bolides has been radically expanded. We are seeing events that, 10 years ago, would have happened in the empty Pacific Ocean and gone completely unnoticed. This raises a critical methodological question. Is some part of the apparent surge in fireball detection in 2026 driven not by an actual increase in the rate of fireballs, but by an increase in our ability to detect them? The honest answer is yes, partially. The GLM and similar instruments have raised the detection floor. We are catching events now that we would have missed before. And this is the critical point, the AMSQ1 2026 analysis controls for this. The AMS baseline is built from witness reports, not from satellite detections. The AMS database has been operating consistently since 2005 and matured around 2016-2018. The reporting infrastructure has been stable. The 3.9 sigma anomaly is not a function of new satellite instrumentation. It is a function of more people on the ground reporting more bright events to a stable reporting system. The GLM is the corroborating instrument. The GLM is the second source. The GLM is what allows NASA to say with confidence, yes, the Cape Cod event was real, and here is its energy, independent of whether any human being saw it. The GLM does not produce the signal. The GLM confirms the signal. This distinction matters because it is the kind of distinction the responsible communicator has to make. New instrumentation changes our ability to see, but the events we are seeing now still have to be measured against the events we saw before, using the same yardstick. The AMS uses the witness report yardstick. The yardstick is stable. The reading is elevated. The GLM, also gives us something the witness report database cannot give us: energy estimates with calibrated uncertainty. Witness reports can tell you a fireball was bright, with rough magnitude estimates. The GLM tells you, in joules, how much optical energy was released, from which the total energy release can be derived with reasonable accuracy. The 230-ton TNT figure for the Cape Cod event is a GLM-derived number, with the calibration and uncertainty bars that come from satellite-based photometry. It is not a guess. We are operating, in 2026, in a fireball detection environment that did not exist a decade ago. And operating inside that environment with all the new tools we have, the verdict is still that something has shifted. That is not nothing. Here is the part that operational planners are increasingly uncomfortable with, and that the public conversation has barely touched. The United States has, as I mentioned earlier, a planetary defense network, a congressionally mandated program to find and track near-Earth objects of 140 meters or larger. That program is run principally out of the Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, with observational support from a network of ground-based and space-based telescopes. The program is well funded by historical standards, internationally coordinated, and has, in the last 20 years, dramatically expanded our catalog of large near-Earth objects. We have found most of them. We can predict their orbits in many cases for centuries. That program does not, by design, do anything about objects smaller than 140 meters. The reason for that design decision is sound. Objects smaller than 140 meters do not, in any single impact event, threaten civilizational damage. A 20-meter object like Chelyabinsk in 2013 can injure thousands of people and damage thousands of buildings, but it does not end a city, and it certainly does not end a country. The risk of a small object impact, integrated over the global population and infrastructure, is real but bounded. The cost of finding and tracking every meter-class object out to Earth-crossing distances would be vast, and the marginal safety benefit would be modest. The current architecture is, in expected value terms, well calibrated for the historical threat baseline. But if the threat baseline shifts, if the rate of meter-class events doubles or triples, as the AMS data suggests it has in 2026, then the expected value calculation behind the current architecture changes. Not catastrophically, but measurably, and there is currently no infrastructure built to handle that shift. There is no warning system for meter-class objects. There is no public-facing prediction service that says, tomorrow afternoon, a Cape Cod-class event has a 15% probability of occurring somewhere over North America. There is no formal interagency response protocol for a 230-ton TNT airburst over a major metropolitan area. There is no civil defense doctrine for ongoing bolide swarm conditions, because the doctrine assumed the swarm conditions did not exist. This is the mismatch I find most striking. The science is detecting a real shift. The instrumentation is improving. The data is being published openly. And the operational infrastructure of warning, communication, and response is still designed for the previous, lower-rate world. Here is what that looks like in practice. On May 30, the Cape Cod bolide produced sonic booms across 9 states. NWS offices in the affected region got hundreds of public calls asking what had just happened. Local emergency management agencies, in some cases, dispatched units before realizing the source was extraterrestrial. NWS Boston, to their credit, issued a public statement within hours clarifying that the booms were not seismic and not weapons-related. But the only reason that clarification existed at all was because NASA's GLM had detected the flash and confirmed the source. Imagine, for a moment, The same event over a country without GLM coverage. Without an active NOAA-NASA bolide detection collaboration, without a public-facing AMS reporting database. The booms happen, the public hears them. The official explanation arrives, if it arrives at all, hours or days later, by which point public speculation has filled the vacuum. In 2026, with social media operating at the speed it operates at, that delay is a serious communication problem. This is why the meta-narrative, the question of how we communicate about events like this, is not an aside, it is structural. The thing the AMS is documenting is, in part, a story about a small mismatch between the natural rate of fireballs and the social rate of explanation. The natural rate is rising. The social rate of explanation is mostly flat. The gap is filled by speculation, and the speculation is what reaches most people. This is the problem the cosmic forecast exists, in part, to address. Not by being faster than the speculation we cannot be, but by being more accurate than the speculation, with sources, with math, with the receipts. So that when the next event happens, and there will be a next event, probably this week, there is a place to come for a calibrated take. The ratchet of speculation only clicks one direction. The ratchet of explanation has to actively be wound. That is the work. This is not the first time fireball rates have appeared to surge. Let me walk you through 3 historical episodes that provide useful framing for what we are now observing. Anchor 1, 1933, the Great Leonid Drought. The Leonid meteor shower, fed by debris from Comet 55P/Tempel-Tuttle, produced extraordinary meteor storms in 1799, 1833, and 1866, events in which observers reported tens of thousands of meteors per hour. Then in 1899 and 1933, the storms failed to materialize. Astronomers eventually understood why gravitational perturbations from Jupiter and Saturn had shifted the densest part of the debris stream off Earth's path. The lesson was that debris streams are not static. They move. Their position relative to Earth's orbit changes on decadal timescales. The 2026 surge, if Vestian, is a snapshot of a particular configuration that will not last forever. The stream will move. The rate will normalize. We just do not know when. Anchor 2. 2008 TC3, the Almahata-Sitta meteorite. On October 6, 2008, astronomers at the Catalina Sky Survey discovered a small near-Earth asteroid, designated 2008 TC3, approximately 4 meters in diameter. The discovery occurred approximately 20 hours before impact. The object entered the atmosphere over northern Sudan on October 7, exploding at high altitude. Hundreds of meteorite fragments were recovered from the impact zone, designated Almahata-Sitta. This was the first time in history that an object was discovered in space, predicted to impact, and observed in the resulting fall. It demonstrated that meter-scale predictions are possible, in principle, with sufficient survey coverage. It also demonstrated how short the warning window is. 20 hours is enough to evacuate a small area. It is not enough to prevent anything. The Cape Cod bolide of May 2026 was not pre-discovered. It arrived unannounced. That is not a failure of the planetary defense system. It is the system operating as designed, because designing for meter-class warnings would require an order of magnitude more survey investment than current funding supports. Anchor 3. 2013, Chelyabinsk. On February 15, 2013, a 20-meter asteroid entered the atmosphere over Russia at approximately 19 kilometers per second, exploding at an altitude of approximately 7 kilometers above the city of Chelyabinsk. The energy release was approximately 500 kilotons of TNT equivalent, more than 2,000 times the energy of the Cape Cod event. The shock wave injured approximately 1,500 people, primarily from broken glass. Chelyabinsk was not pre-discovered. The asteroid was approaching the Earth from the direction of the Sun, where ground-based telescopes cannot observe. It demonstrated, in the most visceral way possible, that the planetary defense system has a blind spot in the sunward direction. And that blind spot can be filled by an object capable of injuring more than 1,000 people. Chelyabinsk shifted the planetary defense conversation in fundamental ways. It led directly to the proposal for the NEO Surveyor mission, a space telescope designed to detect Earth-crossing asteroids by their infrared thermal signature, including objects approaching from the sunward direction that are invisible to ground-based optical telescopes. NEO Surveyor is scheduled for launch in the late 2020s. It will dramatically improve detection of objects in the 50-meter to 140-meter range. It will not, however, change the fundamental architecture for meter-class objects. Those are still in the too small to track, too rare to worry about regime. The 2026 surge is, in some ways, a test of how robust that too rare to worry about assumption is. If the rate of meter-class events is genuinely shifting, and if it stays shifted for a sustained period, then the too rare to worry about assumption needs to be re-examined, not abandoned. Re-examined. Here is what re-examination might look like. 1. Expanded support for the AM-style public reporting infrastructure so the citizen science detection network keeps pace with the rate. 2. Expanded radar surveillance, both planetary defense radars and weather radars repurposed for bolide tracking, to provide independent corroboration of optical detections. 3. Formal interagency protocols for public communication during bolide swarm conditions, so that when the next Cape Cod-class event occurs, the official explanation arrives faster than the speculation. 4. Expanded funding for the meteorite recovery community. Because the scientific opportunity presented by an elevated rate is unprecedented, we may be receiving free samples of a specific protoplanetary debris stream that no spacecraft mission could deliver. At any cost. These are not panic responses. They are operational adjustments to an observed shift in baseline. They are what the responsible version of the conversation looks like. The historical anchors tell us that surges happen, that they end, and that we have always, every time, been caught somewhat by surprise. There is no reason to assume 2026 will be the exception. I want to do something here that I do not see done often enough in this kind of coverage. I want to spend real time with the human cognitive bias that is most relevant to interpreting the 2026 fireball data. And I want to do it because if I do not, you will leave this broadcast with a slightly wrong intuition that will distort how you interpret the next event when it happens. The bias is called the clustering illusion. It is the tendency of human pattern recognition to find structure in randomly distributed data. It is the bias that makes us see faces in clouds, hear meaningful messages in static, and find conspiratorial patterns in independent news events. The bias is not a defect. It evolved because, in the ancestral environment, the cost of missing a real predator pattern in the noise was very high, and the cost of finding a false pattern was relatively low. So the cognitive system was tuned toward sensitivity at the expense of specificity. We see patterns. Sometimes the patterns are real, often they are not. Here is the version of the clustering illusion that applies to fireballs. If you tell someone 5 fireballs happened over America in 4 days, the immediate intuitive response is to look for a common cause. The mind reaches for the single explanation, the thread that ties the 5 events together. This intuition is not stupid. It is, in some cases, correct. Sometimes 5 events do share a cause. But in many cases, The 5 events are statistically independent, each one a roll of dice with its own probability, and the cluster is just a roll where the dice happen to come up similar. Here is the thought experiment that helps. Imagine a wall painted white, and you scatter 43 black dots on it randomly. That is the historical Q1 baseline for events with 25 or more witnesses, distributed across approximately 90 days. Some dots will be close together, some will be far apart. If you look at the wall and you find a cluster of 5 dots close together, you might be tempted to conclude that the painter intended that cluster. They did not. The cluster is what randomness looks like. Randomness is lumpy. Random distributions produce clusters all the time, by chance alone. If your intuition tells you that 5 fireballs in 4 days is unusual, your intuition is being misled by your expectation of evenness. Random does not mean evenly spaced. Random means lumpy. Random includes clusters. So if I stopped there, I would have to tell you that the 5 fireball cluster in isolation is not statistically significant. It is consistent with the historical baseline being unchanged. But that is not the point. That is not what the AMS is reporting. The AMS is not saying, look at this cluster, it is unusual. The AMS is saying, look at 5 months of data, and the underlying rate has shifted. The cluster is consistent with the underlying rate having shifted. The proof of the shift is not in the cluster. The proof is in the integrated count over 5 months. This is the distinction that responsible coverage needs to make and that almost no coverage actually makes. The cluster is the story. The signal is the context. They are related, but they are not the same. If you only look at the cluster, you are vulnerable to the clustering illusion. And you can be talked out of taking the data seriously by anyone who can correctly point out that random distributions produce clusters. If you only look at the context, you have to do statistics, which most audiences disengage from. The honest thing to do is to show you both the visible cluster and the invisible context, and to acknowledge that the cluster is what got your attention, but the context is what should hold it. Sit with that for a moment. The Cape Cod fireball got your attention. The Ohio Valley fireball got your attention. The 256 Report June 2 event got your attention. Those events are visible, dramatic, and easy to describe. They are also the surface symptoms of a deeper pattern. The deeper pattern is in the statistics, in the 3.9 sigma anomaly that the AMS published with the math exposed. The deeper pattern is what the visible events are evidence of, not the other way around. This is the thing the responsible version of this story has to keep insisting on. The events are the data points. The data points sit on top of the distribution. The distribution is what tells you whether the system has changed. In 2026, the distribution has changed. The events are visible because the change is real. That is what separates the AMS analysis from every conspiracy theory and every clustering illusion-driven panic. The AMS did the math. The math is in the public domain. You can run the Python script yourself. The signal is there. Let me shift the timescale forward. If the Q1 2026 surge is genuine, and the AMS analysis says it is, what does the rest of 2026 look like? What are the questions that the next 6 months will answer, and what should you be watching for? Question 1. Does the rate stay elevated through Q2 and Q3? The Vestian debris stream hypothesis predicts persistence. If Earth is currently passing through a stream of material in a particular orbital configuration, the transit will take some specific amount of time, possibly weeks, possibly months, possibly the rest of the year, depending on the geometry of the stream and the velocity of Earth relative to it. A random fluctuation would predict normalization within a quarter. A persistent stream would predict continued elevation. By the end of Q3 2026, We will have enough data to distinguish between these hypotheses with reasonable confidence. Question 2. Do the recovered meteorites confirm a common source? The isotopic and mineralogical analysis of the March 8 European specimens and the March 17 Ohio specimens is ongoing. The critical measurements are oxygen isotope ratios. Different parent bodies in the solar system have distinct oxygen isotope signatures, and matching signatures across multiple events would be a strong indicator of common origin. The lab work takes time. Preliminary results may be available in late summer 2026. Final peer-reviewed publication likely in 2027. Question 3. Are there observable Vestoid asteroids on inbound trajectories? If a recent Vestoid fragmentation event is feeding the 2026 surge, there should be a population of larger Vestoid fragments in orbits dynamically related to the smaller objects we are seeing as fireballs. Some of those larger fragments should be observable with current near-Earth object surveys. The community is now actively searching. Any discovery of a Vestoid in an Earth-approaching orbit would be major news. Watch for announcements from the Minor Planet Center. Question 4. Will there be a larger event? The dice are loaded towards smaller events because the population is dominated by smaller objects. But the same fragmentation event that produces an excess of meteor-class fireballs would also be expected to produce a slight excess of larger objects by the power law scaling I described earlier. The probability of a Chelyabinsk-class event in 2026 is still very small in absolute terms, single-digit % at most, but that is higher than it would have been in a non-anomaly year. Whether the year goes by without a major incident or whether we are caught by something larger will depend on chance. This is the part where I have to be careful. I am not predicting a major event. I am describing how the probabilities have shifted on the margin given an elevated baseline. The probabilities of a major event in any given year are small. They remain small in 2026. They are slightly less small than they were in 2024 or 2025. Slightly less small. Sit with that. Question 5. Will the public communication architecture catch up? This is the question I find most actionable. The science is being done. The data is being published. The instruments are working. What is lagging is the bridge between the science and the public. The consistent, calibrated, accessible explanation that arrives faster than the speculation. The next 6 months will tell us whether the gap closes or widens, whether NASA's Meteoroid Environment Office gets the support to communicate in real time, whether the AMS gets the resources to scale with the rate, whether the news cycle, when the next event happens, reaches for the AMS analysis or for the conspiracy framing. That is partly on the institutions. That is partly on the journalism. That is partly on you, the audience, which sources you choose to trust, which channels you choose to amplify, which framings you let into your head. You have agency here. The 2026 fireball year is not just happening to you. You are part of how the country processes what happens. This is the meta layer of the story that I find most under-discussed. The fireballs are physical events. The understanding of the fireballs is a social process. Both layers are real. Both layers are evolving. Both layers will determine in different ways how the next 6 months unfold. I have spent 16 parts walking you carefully through the data. The signal is real. The signal is physical. The signal is statistically significant. The most likely explanation is a debris stream of finite duration. The probability of a major event is slightly elevated but still small. The infrastructure is adequate for the previous baseline and somewhat behind the curve for the current baseline. The communication architecture is the weakest link. Now I want to say something that is harder to say, and that I have been building toward this whole broadcast. The 2026 fireball surge, even if it is entirely natural, entirely Vestian, entirely a temporary debris stream transit, is a preview. It is a preview of what a more active near-Earth object environment looks like, operationally, from the inside. It is a preview of what kind of public communication challenges we will face when, not if, when a more significant event occurs. The next Chelyabinsk-class event will happen. The historical base rate is approximately one every 50 to 100 years. We have already had one in 2013. Statistically, we have decades before the next one, but statistics is not a guarantee. The next one could happen tomorrow, or in 2090. We do not know. We do know that the probability is non-zero in any given year, and the probability is, by the AMS analysis, slightly elevated in 2026. If the next Chelyabinsk-class event happens during the current debris stream transit, the public response will be shaped by the framing established now. By whether the 2026 surge was correctly contextualized by the time the bigger event arrived. By whether people understood that elevated rates do not mean catastrophe, that catastrophe and elevated rates are distinct phenomena. That the responsible response to elevated rates is monitoring and patience, not panic and not denial. Here is the part most coverage has not yet grappled with. The default public response to a Chelyabinsk-class event, given the current information environment, will not be calibrated. It will be either far too alarmed or far too dismissive. There is currently no broad public framework for understanding what a high-altitude airburst that injures 1,000 people, but kills none means in the context of a 1 in 50-year baseline. There is no public framework for the difference between an asteroid hit Earth and an asteroid disintegrated in the upper atmosphere above Earth. There is no public framework for the worst happened, and the casualty count was below the highway traffic fatality count for the same day. The 2026 surge is an opportunity to build that framework, to use the elevated rate of small events as a teaching moment for the eventual larger event, to get the language right, to establish the institutional reflexes, to practice the communication. That is, in some sense, what the cosmic forecast is for. Not to be the channel that breaks the next fireball. To be the channel that, when the next fireball breaks somewhere else, has already done the work of making the audience capable of interpreting it correctly. The work is upstream of the event. The work is in the framing. You are watching the framing being built. You are part of it. Every viewer who finishes this broadcast and shares it with someone who would otherwise have been reached only by the panicked version or the dismissive version is doing the work. The cumulative effect of that work is, in the aggregate, a slightly more resilient public information environment. That is not nothing. In a year where the dice are slightly loaded, slight is enough to matter. I do not know if I am being too philosophical in this section. I think the data justifies it. I think the data this year justifies a certain seriousness about what we are watching. 5 fireballs in 4 days, sitting on top of a 5-month statistical anomaly, sitting on top of confirmed meteorite recoveries from a probably common parent body, sitting on top of radiant clustering at multiple sky locations, sitting on top of GLM satellite confirmations. That is a story that deserves to be told as carefully as it can be told. And the telling of it is itself part of the story. The window for getting the framing right is open right now. It will not stay open. Once the next big event happens, the framing will be retrospectively imposed, and the framing imposed in real time, in the panic, by the speed of social media, will be the framing that sticks. The work has to happen before. The work has to happen now. The work is happening in places like the AMS, like NASA's MEO, like this channel. And it is uphill work because the gravitational pull of the news cycle is towards simpler stories. This story is not simple. The data does not allow simplicity. The honest response to the data is sustained attention, repeated context, and patience with complexity. The cosmic forecast is committed to all three. I want to bring this broadcast toward its closing arc by sitting with the implications of the AMSQ1 2026 analysis one more time, in the most condensed form I can manage. The math does not work for a reporting artifact explanation. The math controls for camera proliferation, for AI-directed reporting, for seasonal effects, and the 3-9 sigma anomaly remains. The math does not work for a clustering illusion explanation. The cluster of late May to early June is small enough to occur by chance, but the 5-month integrated count is not. The math does not work for a single event explanation. There is no individual cause that explains both the radiant clustering at aphelion and at high declination. The Vestian debris stream hypothesis explains one of those clusters cleanly. The other one, the high declination cluster, requires either a second debris stream or a more complex explanation. The math does not work for a "we just got better at detecting" explanation. The witness report baseline is the relevant baseline, and it has been stable for nearly a decade. The new instrumentation corroborates the witness data without producing it. The math does work for one explanation. The math works for there is more material in Earth's path in 2026 than there has been in any year since the AMS reporting system matured. That sentence is consistent with every piece of data we have. It is consistent with the witness counts, with the sonic boom rates, with the meteorite recoveries, with the radiant clustering, with the satellite confirmations. It is the simplest explanation that fits all the evidence. It is also, perhaps, the most operationally important conclusion that can be drawn from the data because it has a forward implication. If there is more material in Earth's path now, the question of when there will be less becomes empirical. The answer is when the transit completes. Whenever that is, we do not know. But the rate cannot stay elevated forever. Debris streams have finite extent. Sometime in the next quarters, the rate will normalize, possibly soon, possibly later in 2026, possibly not until 2027. Here is the part that ties it together. Whether the rate normalizes in 3 months or in 3 years, the lesson of 2026 is the same. The near-Earth environment is not a stable background. It is a fluid environment with periodic, partly predictable, partly surprising shifts. We have built our planetary defense architecture, our public communication infrastructure, and our cultural intuitions around the assumption that the environment is stable. The 2026 data is, in a small way, falsifying that assumption. The infrastructure we have is good for what we built it for. It is not optimized for an environment that varies on the scale 2026 is revealing. That mismatch is small in any given year. Across decades, with multiple surges and multiple normalizations, the cumulative weight of the mismatch grows. The recovery gap between what the environment is doing and what our institutional reflexes are prepared for is not zero. It is widening slowly. This is the kind of thing the cosmic forecast exists to track, not the catastrophic event, the slow accumulation of small mismatches. The way that the operational baseline of the upper atmosphere is, year by year, becoming something we know slightly less about than we thought we did. The way that the calendar of fireball season, the February through April window, is, like so many other calendars in 2026, becoming less reliable as a guide to what to expect. The gap is widening. The dice are loaded. The window is closing on the period during which we could have built the communication architecture without urgency, and the period during which we have to build it under pressure is beginning. That is the operational reality. I want to give you in this section the practical takeaway, because everything I have walked you through up to this point has been about context, math, and framing. None of that is useful unless it changes how you operate. Here is what you should do. 1. Bookmark the American Meteor Society Fireball reporting page. If you see a fireball, report it. The AMS depends on citizen science reporting, and the quality of the data we have all been discussing in this broadcast is a direct function of the number and quality of public reports. You are part of the dataset. Your report matters. Reports filed within the first few hours of an event are particularly valuable because they capture trajectory information before social media confuses people's memories. 2. Subscribe to the Cosmic Forecast so you do not miss the next analysis. This story is not over. The next major event will happen, probably within weeks. When it does, the question of how to interpret it will require the context this broadcast has built. That context degrades fast if the audience is not maintained. Help us maintain it. 3. When you see a fireball-related headline that uses panicked or sensationalist framing, Earth under attack, mystery fireballs surge, government hides asteroid threat, slow down. Check the source. The AMS, NASA, the Center for Near-Earth Object Studies, and credible academic astronomers will give you the calibrated take. The sensationalist sources will give you the viral take. Both versions will reach you in 2026. Choosing which one to amplify is a small but real form of civic participation. 4. If you live in a region prone to fireball sightings, and that, given the 2026 rate, is most of the continent, know what a sonic boom from a high-altitude bolide sounds like. It is a rolling, multi-stage concussion, often several seconds long, with no visual lightning to accompany it. If you hear that without preceding lightning or military aircraft activity, do not panic. Wait for the GLM-confirmed explanation from NASA. It will come, usually within hours. 5. Talk to people in your life about this story, not in an alarmist way, in a curious way. The 2026 fireball surge is one of the more scientifically interesting things to happen in the near-Earth environment in a decade. Sharing it widens the base of people who, when the next event happens, will reach for the calibrated explanation rather than the panicked one. Here is what you should not do. 1. Do not panic buy supplies, panic relocate, or panic anything based on this broadcast. The rate of Meteor-class fireballs has doubled. The rate of City Killer-class events has not measurably moved. The expected value risk to any individual person from the 2026 surge is essentially indistinguishable from the historical baseline. The change is in the science, not in your day-to-day risk. 2. Do not dismiss the data because some of the coverage has been bad. The data is good. The AMS analysis is rigorous. The fact that some headlines are bad is a feature of the news ecosystem, not a flaw in the underlying science. 3. Do not amplify content that claims the fireballs are evidence of an extraterrestrial threat, a hidden planet, a weapons test, or anything similar. Those framings are wrong. We walked through why. Amplifying them displaces the calibrated framings that the public needs. 4. Do not let the urgency of the story extract your attention from other things in your life that also matter. The cosmic environment is one frame among many. The story will still be here next month. So will your kids, your job, your community. Take what you need from this broadcast and then put it down and live your life. This is the discipline of operating inside elevated risk environments. You acknowledge the elevation, you adjust your information consumption, you participate where you can, and then you go on living. The world has been here before. We have always lived inside risk distributions that are partly understood. Knowing slightly more about the current distribution does not require living in a state of vigilance about it. It just requires being a slightly better informed person than you would otherwise have been. That is the work. That is what the cosmic forecast is asking of you. Slightly better informed. Slightly more calibrated. slightly less reachable by the panic version of the story. The cumulative effect of millions of slightly better informed people is the difference between a society that handles the next big event well and a society that handles it badly. You are part of that cumulative effect. So is everyone watching alongside you tonight. I want to close on the question that the AMS analysis poses but does not answer, because the open question is the part of this story that I find most worth sitting with. The question is this: if the 2026 surge is real, and the most likely explanation is a previously unidentified debris stream, possibly Vestian, possibly cometary, possibly both, then the deeper question is, how often do we transit streams like this without noticing? The AMS reporting infrastructure matured in 2018. Before that, our ability to detect a surge like 2026's would have been compromised by the smaller, less coordinated witness network. We may have missed prior surges entirely. There may have been a 1992 surge, a 1976 surge, a 1954 surge. We do not know because the data quality before the modern instrumentation era was not adequate to detect them. That is the open question. The 2026 event may be unprecedented in the modern record. It may also be a normal feature of the near-Earth environment that we are only now equipped to see. Both are scientifically interesting. Both have implications for how we should expect 2027, 2030, 2040 to unfold. We do not know which one is true. There is a beautiful symmetry in not knowing. 20 years ago, we did not know how often Earth was struck by meteor-class objects because we lacked the detection infrastructure to count them. Now we know that approximately, in normal years. We do not yet know how often Earth transits debris streams of the kind 2026 has revealed. We are building the detection infrastructure to count those in real time this year. By 2030, we will probably know the answer. The answer will be one of the durable scientific findings of this decade. That is what science looks like when it is working. The instruments improve. The data accumulates. The questions sharpen, the framing matures, the public slowly gets better informed, the infrastructure slowly catches up. The communication architecture slowly learns to handle increasing complexity without breaking. It does not always work. There are years where it breaks. There are events that exceed the infrastructure's capacity to explain them, and the gap between the science and the public widens fast and dangerously. Whether 2026 ends as a year in which the infrastructure caught up, or a year in which the gap widened, will depend on choices made by institutions, journalists, audiences, and citizen scientists alike. The choices are being made now. They will be made over the next 6 months. They will be cumulative. If you have watched all the way through this broadcast, 20 parts, more than 20,000 words, 4 hours of careful walkthrough, you have done a small but real piece of that work. You have, by your sustained attention, contributed to the kind of audience that makes calibrated coverage possible. Without that audience, the work does not get funded, the channels do not survive, the framing does not propagate. You are the reason this kind of coverage exists. You are the reason I can spend 5 hours preparing a broadcast like this, rather than producing something faster and less accurate. So as we close, I want to ask you the question I asked at the beginning, and ask it differently now that you have the full picture. When a 3.9 sigma signal in the near-Earth meteoroid environment is published openly, with the data exposed by the oldest amateur meteor organization in the world, and the public still mostly does not hear about it, what does that say about the relationship between modern science and modern attention? Drop your answer in the comments. Tell me where you are watching from. Tell me what time it is where you are. Tell me whether, when you finish this broadcast and walk outside tonight, you are going to look up at the sky differently than you did before. That last question matters to me, personally. The work is worth doing if it changes how a small number of people see the sky. Even one person, even you. The cluster of 5 fireballs over 4 days is, in the end, not the story. The cluster is the prompt. The story is what the cluster makes us notice. About the orbital environment, about the detection infrastructure, about the gap between the science and the public, about the patience required to operate inside a slightly shifted baseline. The story is not over. The story will not be over for months. The fireballs will keep arriving. So will the explanations. The dice are loaded, slightly, for now. For some duration we cannot yet measure. This is the Cosmic Forecast. Thank you for watching to the end. Subscribe so you do not miss the next analysis. Share this broadcast with the one person in your life who would most benefit from a calibrated version of this story. And keep your eyes on the sky. The window is open. The signal is real. The work is ongoing. We will be here for the next one.